Does anybody need this many power supplies? That was a question my wife asked. I mean, really, who asks that kind of question? Of course we need this many power supplies. If you guys want to see some of these power supplies, see a few that I've built, see the ones that I use most often, my smallest and my largest power supply, well, stick around. We're going to get right into it. Today, I wanted to go over some real brief information about power supplies. I had a question in my comments, and I thought now would be a good a time as ever to kind of go over just some basics of power supplies, and I'll show you, if you want, stick around till the end, and I'll show you guys the power supplies that I use most often. I'll show you my smallest and largest power supplies. But I want to start here just with a few that I had in my room here. I brought these out just so I can kind of show you guys. These are a few that I use, some more so than others. But let's just start with the basic power supply, which really just a battery, right? I mean, this is a pretty basic power supply. It's not very useful in that it only produces 1 voltage. So what you can do with it is fairly limited. And that also is what this is here. This is a little power bank, and this produces just 1 voltage. In this case, it produces 5 volts. Again, not very useful if you're trying to do work on electronics. Sometimes it is. If you're trying to work on something that needs 5 volts like a phone, then this is an ideal solution. If you're needing something that is lower voltage than this, it requires you to be a little creative. And that's also what I want to go into in regards to how you can use something as basic as these two things to perform some of the function that some of these do. So let's start with just the basic battery, and I'm not going to use this one. We'll use this in a bit. I want to start with this one first because this is pretty readily available. They produce 5 volts, and all you really need to get one of these to work, let's see if I have it here. Yes, we've got just a USB cable. So when you take this and say plug it into here and turn this on, now coming out of the end here is 5 volts. And again, this isn't very useful unless you just need 5 volts. But if you needed less than that, then you kind of have to get a little creative. And what I have here is just something pretty crudely cobbled together. This is one of the resistors that you've seen on this channel before. But I want to show you guys just a quick way that you can take a known voltage like 5 volts here. Let me scoot some of these out of my way so you can kind of see this. You can take the 5 volts that comes out of this, and we could make it do something a little more useful in the event, say you have something that needed, say 2 volts or 3 volts. The 5 volt power supply here isn't going to be much help to you. So I'm going to turn this meter on. We're going to set it here, and I'm going to show you guys coming out of this battery pack. As you can see that 4.9. So it might as well just be 5 volts, right? Well, because I use this resistor here and I put it in a configuration, it will allow me to vary this slider here and then vary the voltage that is coming out of the power supply. In this case, we'll see 2.2. And disregard the negative. It's only because I've got these leads reversed around. But you'll see here, we've got 2.2 volts. So we took a 5 volt power supply, ran it through a voltage divider. And again, it doesn't need to be something like this. I just sometimes like large items because it's easy to see and visualize. And then likewise from this side as well, you will have that same 2 volts coming from this side. And if we move the slider, you can actually produce more or less volts depending on where this slider is. And this is just really a potentiometer or a voltage divider. So now that I moved it a little bit, now we'll have 1.6. And then also if we switch this around and go to this side, now take that 5 volts minus the 1.6, and then we've got 3.3 on this side. So this is a useful way to take a known, really a standard source here, 5 volts in this instance, and make it be a little more useful. Though this, I mean, let's be honest, this is kind of crude to do it that way. So another option would be to use something like this battery and something like this. This is called a buck boost converter, because in this scenario, if we needed this to produce more voltage than 5 volts, we're really limited. All we can do is produce less than the 5 volts by going with this method of using a voltage divider. So if you need less than 5, that would be great. If you had a 12 volt supply, you needed less than that, using something like this could work. But when you need more voltage than it can produce, so for example, this produces about 4 volts. Well, what if I needed 6? You really can't get that by using a voltage divider, but you can get it by using a little chip like this, a circuit board like this. This is called a buck boost converter. And what this does is it can take the voltage and it can vary it up or down. In this case, we'll see that this is producing 5.6 volts. What you can do is you can vary the voltage up or down. So in this instance, 10 volts, 12, 15, 17, all the way up 20. This will, I don't know where this tops out, 30 volts. Yeah, 27, 28 volts. Or you can go down. And it's quite crude in that the potentiometer, as it turns, it's not very fine. And it's only going down to its lowest voltage. So this is a boost converter. This is not going to be a buck converter. This will not drop the voltage below what the battery is producing. You just have to remember, buck converter drops it down below the voltage, a lot like what we did with that resistor when we put it in. It can lower the voltage. In this case, it only raises the voltage. So that's where you could remember that pretty easily as boost, boosts the voltage. So you can see it there. By me turning this potentiometer, the voltage is actually increasing, 6, 7, 8. So this is really handy. Let's say you had something that took a 9 volt battery. Well, in this instance, now with just a 4 volt lithium cell and this little chip here, you could make this produce 9 volts. So it's really kind of handy for doing stuff like that. But let's go on to something that's a little bit more useful. I'm going to pop this out of here. This was one that I made a while back. And what this does is this takes line voltage, so 120 volts, and then steps it down and then puts it out of these 2 ports. And something this has, which is really useful, is you've got 2 potentiometers here. A lot better than this one that was in this. You can see, let's see if I could get you a close-up of that. See that little potentiometer? Well, it's not the best. It's best if you just set it at a voltage and then kind of leave it. The nice thing about this one is with a screwdriver, you could turn these here and increase and decrease the voltage and the current. And that's where we're getting a little bit more complex than just your standard power bank, because what we've done so far is only increase or decrease the voltage. But when you're working with electronics, you often want to also be able to increase or decrease the current. And there's various reasons when that's important. For example, if you're not sure if the item has a short circuit, you could lower the current way down and then plug it in and then slowly raise the current to its operating current. And you could then continually increase the current, and it should not, the current should not increase if the item is working properly. So having the ability to adjust the current, in this case, when you see CC, let's see if I can zoom in there. See that? CC and CV. Well, CC means constant current and CV means constant voltage. I'm going to get this one out and show you one that runs off battery. These are the same converters here. So what you can do now, in this case, this has got batteries in it. As you can see here, we've got some lithium batteries, and this is fairly simple. And then once this goes on, it shows our input voltage of 8.23 volts. There we go. Our output voltage is 9 volts, 9.3. It's pretty bright in here, so we can't really see that. And this is hooked up to a little 12 volt LED. But you can see as I increase this voltage, this number here is increasing all the way up 10. 11. So I'm literally taking the input voltage and increasing it or decreasing it. And remember, we think we had like 8 volts in. In this case, we can actually go down below that 8 volts. So this is a buck boost converter. Now we're at 4 volts, 3, 2, so we're getting way down. 1. So you can see how we took the initial input voltage and we're now increasing or decreasing that voltage. So it makes it really handy to where if you do want to plug something in that way, for example, you can take these here and they just plug in. And then you've got that same voltage coming out of alligator clips. So it makes it really useful for working on items. And then the current, I want to talk about that briefly. So the constant current mode, right now this is drawing, as you can see there, let's see if I can get that, it's 133 milliamps. That's what is being drawn by this. And as we increase the voltage, you'll see the amperage is also increasing. Now we're drawing 200 milliamps. At its full 12 volts, let's see, this is drawing 300, let's just say 300 and call it 330 milliamps at 12 volts. Well, watch what happens if I lower the amount of current. See how the current is dropping down, and so is the voltage. So what this allows us to do, and you can see the light is just now starting to pulse. I don't want to keep it flickering in front of the camera here. But this constant current mode, and now watch this, this is the part that really is important. A lot of people don't understand this. We're now at that threshold, right? If I go down, you can see 250 milliamps. And as I go up, we reach the maximum that it's drawing, 330. Now watch what happens as I increase this. Nothing is going to happen. The light's not going to get brighter. It's not going to draw more current. I've got that thing really kind of much higher than what it was. But you can see that it's not drawing any more than what it draws at that voltage. So that's something that's often misunderstood, is that if you have more current being supplied, it doesn't necessarily mean that the item is going to use that current. So that is how a constant current mode works on a power supply. I wanted to show you guys this one here because this is a more recent one that I built. It's a little bit nicer in that it's got a knob here to turn rather than using a screwdriver. And these are really inexpensive as well. I mean, I don't think this cost more than 20 bucks to buy one of these units. I 3D printed the housing, which makes it kind of nice if you have a 3D printer. And then I did a few things like put a little fuse in the back. I put a little jack where you can power it with an external power supply anywhere from 6 to 36 volts. I put some bad dog stickers on it, which makes it run that much better, right? And now what you can do with this one, I also put a second power switch here, and you'll see this has a power switch here. So why would I want a second one? And there's a reason for that, and that is when you turn this on, this is drawing current. If I turn this off here, watch what happens. You'll see that this still has a very small residual current draw. And I never like that in my electronics. I like that when I turn it off, it's off and it's not drawing current, because this is running off of batteries as well. You'll see here I'm using a few lithium cell batteries, and this one is a little more complex than that other one that we saw earlier, but it's basically the same thing. In this case, I have it to where it takes a voltage from the back here. It can take batteries. Also, I used that same trick that I did in one of my other videos where I inserted some magnets in here and then just epoxied some metal on the cover here. And then once you kind of get it in place, that's it. It just kind of stays in place. So it's nice to be able to kind of open it up quickly and do anything you need inside. But this has been a really useful tool in the shop here. The way this works is very similar to this one here that we were just working with. What this does is it has your input voltage, and you can see right now this is getting 11.8 volts from the batteries that are in there. And then you can lower or increase the voltage. This will produce 5 to 36 volts. So this is a buck boost converter, and it will produce up to 5 amps, 90 watts. Though I would never really take when they manufacture these, some of these are overseas, and they definitely overestimate what they can do. So if you wanted something that was going to run at 5 amps, 90 watts, you probably want to buy something that is substantially larger so that it is able to handle the heat dissipation. This is nice that it has a fan built into it, and that's why I really like this unit. You can see the fan down in there. So then what you can do with this, let's turn this back on. And right now this is producing 10 volts on the output. So if we come over here and we go to out, we can see it says 10 volts right there. So the really nice thing about this is there's just push buttons and dials, so you don't have to use a screwdriver. It's really much more useful. So if we want to set the voltage, let's say we were working on something that needed 9 volts, right? So you can toggle over here, and now we're at 9 volts. Hit voltage set, and you can see we're producing 9 volts now. So if you had something that took, say, a 9-volt battery, this is ideal for that. If you need something that's going to produce 1.5 volts, kind of like a 1.5 volt battery, now we're producing 1.5 volt. It's really kind of nice for that. And I have tested this up to 70 watts, and it was running just fine. This is useful in the shop here for anything that you're troubleshooting, testing. Having something that allows you to vary the voltage. I used this just most recently for a radio I was working on. Having something like this and something like this, which is just a universal, where's it at here? A universal plug that fits a varying number of devices. You can just hook this up. So you can take the negative to the negative, positive to the positive, and now coming out of this port right here is the 1.5 volts. Something really handy about these and how I was able to use it is I had something that needed reverse polarity. So right now, as convention, the center pin here, this is positive and this is negative. That's usually the way things are done, but sometimes you need it to be the other way around. So in this case, really all that's needed is just to switch the polarity here. Take the positive to the negative and the negative to the positive. Now, this is what's called center pin negative. So what's happening here is this is negative with respect to this. Let's show you that really quickly just so you can see what I mean. So now, where this is normally positive, watch the sign on here there. So see that negative? So now we're producing negative 1.5 volts. It's actually not negative, but it's with respect to the center pin here. If I put this back to the way it was, 1.5 in the positive way, meaning the center pin is positive. So that's something you'll always want to check. Look at the back of your power supplies and you'll see that. Let me show you guys this here. See this symbol down there where it shows that? Well, that shield is negative and the center pin is positive. This is fairly common, but if you want to be really sure of the way that you've got your polarities, because you could do some real damage. This was another little power supply that I just kind of cobbled together. I cut the end off and I put some alligator clips, and this produces 12 volts at 2.5 amps. So sometimes when I have something that requires 12 volts, this is really handy. If it's just a standard voltage, kind of like what we were dealing with early on when we just had a standard voltage. Sometimes you just need 12 volts or you just need 5 volts. In that case, these work really well for that. Sometimes you need something that is able to vary the voltage and the current. And this also has the same type of feature that we saw on this. It has the current limiting capability. And I'm going to show you one time here. What I'm going to do is I'm going to short these together. And in doing so, you'll see this gets into a constant current mode. See that little CC? So what's happening now is this is capping it at 300 milliamps. So if I wanted, I could adjust the current. We're going to do the same thing, and I'm going to lower this down. Now it's drawing a maximum 100 milliamps. If I needed it to do more, now it's drawing 500 milliamps all the way up. Now it's drawing 1 amp of current just because these are shorted out. So let's set that. So now we're producing 1.5 volts with a max of 1 amp. Then what I would do is I'll just set this back, because I usually like my stuff to be around that 500 milliamps, 250, 300. I mean, I'd always rather be on the safer side so as not to do any damage to something that I would be checking. So now if it had a dead short, you'll see it shows that it's in constant current, and it also is capping it at 200 milliamps. So we're going to plug this light in. And I know this light is a 12 volt light. So what I'm going to do is I'm going to go into my voltage, and I'm going to change this to 12 volts. Now we are drawing 12 volts, and you'll see the constant current mode is limiting. It's saying, hey, you've got it set to 200 milliamps, and it can draw more than that. So now watch as I increase the current. We're going to do it in small steps here. Now we're at 300 milliamps, and it's still limiting. 310, 320. Watch when we get up around its maximum here. 400 milliamps. Oh, I might have to. I think I have to. Yes, I have to set it. Yeah. So you have to hit the set button then to kind of lock it in. So right now it's saying that this is in constant voltage mode. So voltage is where it's being capped. And current, it's drawing a maximum of 325 milliamps of current. So it's a really useful tool. In this case, I'm going to shut this down. And I want to take you guys, you know what, while we're here, let me show you guys this, because this is something in regards to power supplies that we haven't talked about yet. And that is AC power supplies. All the ones that we've kind of looked at so far have all been DC power supplies. A battery is a DC power supply. This little boost converter that we had here was a DC power supply. So kind of all these here. This is an AC power supply, and oftentimes you want to provide AC voltage. And this is just a nice little, it's from a microscope, and it has a few little settings here built into it. So you can go at 6 volts, 8, 10, 12, 14 volts. So this has a little adapter here you can plug in, and then this produces AC voltage on the output. So it's handy for some things that use low voltage AC, but you have to be aware that none of these produce AC voltage. You need an AC power supply if you want to produce AC voltage, and that's where something like this comes in. And you can buy AC transformers. If you look on the back of some of these, you'll actually see, in this case, you can see that this is DC voltage. It shows its input, and then it shows its output, and it shows the output there. If this were an AC power supply, I'll see if I can cut over to one and I'll show you guys an AC power supply, then that means it's going to do a similar feature as this. So, you know, while I'm still in my lab here, I just looked over my shoulder and I saw a couple more power supplies. This is a battery eliminator. It takes 110 volts, 120 AC. Let me turn it on here. Hopefully we don't get drowned out by the fan. And then what this does is this runs an exhaust fan. I've got this knob here on the top that I can use to increase or decrease the speed of the fan. But this unit here is really useful to exhaust fumes when I'm soldering. Let's see if we could see in the back here. This, yeah, it's pretty rough to see, but this produces 55 amps at 13 volts. So this thing is really capable. And then going over here to the right, this is another one that's capable as well. This is a Harrison Laboratories It's a nice power supply. This is a constant current, constant voltage unit as well. This is probably one of the more accurate units that I have. But it has a fine and coarse adjustment. Again, it has that constant current, constant voltage mode. So this thing is really handy to use in diagnostics and to supply power to devices under test. It might be the most accurate that I have, but when we go into the garage, I'll show you the one that I think probably takes the cake as being the most accurate. And then I see there's a couple more here I wanted to show you guys just before we get out of here. So back in the day, these are power supplies that are built into breadboards. So this is a little Heathkit prototype experimenter, and then also another one here. This allows you to take the power coming from your wall outlet, it converts it, and then you can hook it right up to your breadboard, so it makes for a little more efficient prototyping. So here's a few more of the power supplies I was telling you about. Let me get this out of the way here. This is a little Lambda power supply. It's a linear power supply. And then going to the right here, this is an ICO DC power supply, also linear. And then as we pan up, you're going to see this is a matching ICO AC power supply. I use this one quite a bit. It's a nice power supply for providing AC voltage, a lot like this one here on the right. This is also a AC power supply, and it's quite handy. Coming up from that one, this is a Heathkit power supply that I use. I used to use it all the time. It's what I had, and it produces some varying voltage. This is the one I use all the time. This is my Variac, which is really in essence a power supply. It produces AC voltage, but this one by far is the one that I use the most. I use this thing just about every day. It provides DC voltage, and it has a constant current and constant voltage feature. So this one is kind of what I was explaining in the video. This is really handy when you're troubleshooting and you don't want to supply too much current to a device under test. You can limit the current with this, so it's really helpful. It's not super accurate. That's what this one here is. This is a really accurate power supply, but it only produces in the millivolt range. But you can see here by this knob how accurate it is. You kind of take and you put this battery inside of it. It's a little AA battery, and then you can dial in very precise voltages. But again, they're very small voltages as compared to this. This thing is one of my largest power supplies regarding the amount of voltage it produces. I mean, take a look at this here. Yeah, this thing produces some serious voltage. That's going to do it for us here. So if you have any questions, leave them in the comments down below. Have a great day. Enjoy the rest of your day or evening, depending on what part of the world you're in. We'll see you on the next video. Bye for now.